Welcome to Brain Vision.
Okay, so we're doing chapter 26, problem 55. It says our galvanometer has a sensitivity equals 45 kiloohms per volt and an internal resistance R internal of 20 ohms. It says, how could you make this into part A, an ammeter that reads 2 amps at full scale? Okay, so first, the current for full scale deflection is just 1 over the sensitivity, as we did before. So the current here is 1 over the sensitivity, or 1 over 45,000. And this is the same as 2.222 times 10 to the negative 5 amps. So to make it an ammeter out of the galvanometer, a shunt resistor must be placed in parallel with the galvanometer. The voltage across the shunt resistor must be the voltage across the galvanometer, and the total current is to be 2 amps like our problem suggested. So if you want to see what this means, if you look at figure 2628, it will show you a circuit diagram of what we're talking about here. But the key thing is that we take the galvanometer current times the resistor, the shunt resistor added, and this is equal to the current times the resistance. Okay? This is the current through the shunt resistor times the resistance of the shunt resistor. So if we take our let's first of all rearrange this, because we're trying to figure out what we need to add the shunt resistor, but what resistance does it need to be? So we know that the resistance of the shunt resistor is given by Ig little rg over Is. And we want the shunt current here to be 2 amps, as the question stated. So this is 2.222 times 10 to the negative 5 amps times 20 ohms all over 2 amps. So the shunt resistance or current, I wasn't quite clear on this. This isn't actually 2 amps. We want the full current to be 2 amps. But the full current is given by the shunt current minus the galvanometer current, because these are going to be diverging at that point. So that means this Is is actually 2 amps. That should be a plus, sorry. 2 amps minus Ig. So this is 2.22 times 10 to the negative 5 amps times 20 ohms all over 2 minus 2.22 times 10 to the negative 5 amps. Okay, so now this is what we want for this to set up, and if we plug that in, we see a resistance of the shunt must be 2.222 times 10 to the negative 4 ohms. Awesome. So we place a resistor with this resistance in parallel to our galvanometer to turn it into an ammeter. Simple as that. Let's move on to part B here. Part B asks us to, how would we make this into a voltmeter reading 1 volts at full scale? Okay, so we should know that if we look up at, or you can look up at figure 2629 to see what a voltmeter looks like here instead of the ammeter circuit diagram, but we know that the full voltage here is given by the galvanometer current plus times just the resistance in series. So this is Rg plus an R, because to make it a voltmeter, we just add in a resistor in series to the galvanometer, and then this is just Ohm's law. Okay, so if we're trying to figure out how big of a resistance to add, we know that we want Vf to equal 1 volt. So we can take R, solve for it, and this is Vf over Ig minus Rg. So we have 1 volt over 2.22 times 10 to the negative 5 amps minus 20 ohms. And if we plug all that in, this becomes roughly 45,000, roughly there, ohms. So to make it a voltmeter of that specification, we need to add 45 kiloohms of resistance in series to our galvanometer.